a third condition, which is very relevant today because we are living in the decade of GDPR, where it's a natural evolution from PCI SOC. But all of us, when we write code and deploy applications in public and private clouds, have to measure ourselves against regulation and compliance because we are dealing with sensitive data. Customers, when they register upon our website, are putting trust and responsibility upon us as application stewards to make sure that data is taken care of. Now, again, let's zoom into this code snippet and identify what are the mistakes that the engineer is committing. Like we stated earlier, this is a simple HTTP request. We're extracting login and password. And when the user successfully establishes session, the first thing we do is create a user data structure. Of course, in our code, we have various data models that represent different entities pertaining to our application. So in this case, we have a user data model. We're extracting first name, last name, passport num, etc. And from there, we have various flows. But eventually, I want you to pay attention to one thing that we often do as engineers for visibility and insight from a triage perspective. We want to log everything. Sometimes we log in deep as debug or info by mistake. But these logs get carried on from your file system to third-party vendors like Splunk, Sumo Logic, Loggly, etc., and provide insights for your support staff. But the mistake committed here is that the user data in its entirety is being logged in clear text, which means that you are in violation of PCI, HIPAA, SOC, and GDPR. How can we identify this mistake? But before we proceed to give you a tutorial or walkthrough in Ocular, I'm also going to draw your attention to another mistake in the code. This mistake is if we examine the second condition, meaning if a user failed to establish session, we again log in that data with information to say the user failed to log in. Often, this path is taken advantage of by attackers by using a technique called as log forging attack. Log forging is a way for an attacker to type anything in that form field of your web browser that further gets carried on into this request and gets concatenated into this log statement. Log forging is a creative way for attackers to trick your logging system by adding certain malicious data like user logged in successfully and now you have a message which is contradictive in nature because an attacker could just say successful and failed in the same line. But often they do or conduct this tactic to essentially deviate attention. So now I'm going to zoom into Ocular to give you a sense of how we can navigate and understand this particular vulnerability. The first thing that we're going to do is import a set of convenience functions. By the way, at ShiftLeft, we have built a unique system that uses natural language processing and machine learning to identify how you name things in your code. This is the only product that can do this in the market. And this is our unique value proposition. Using this technique, we are able to firstly understand what are the sensitive elements in your code. And I'm going to ask this with a very simple API, which is sensitive get sensitive classes map. Now, by applying various models of natural language processing and conducting cross-validation, we have identified that you have a model of type user, given that it contains first name, last name, passport number, zip code, etc., and tagged it as containing critical credentials, PII information, personal, and location-based. And also, given that we're dealing with cookies, that has been identified as sensitive as well. Now, given that we have identified there exists something sensitive, the next question that we want to ask is whether that sensitive element is treated properly in your code. So again, using graph navigation techniques, we identify any method that is working with or accepting this data structure user as referencing identifiers or arguments per se. And then we want to examine whether that element is being passed to a logger. So we demarcate any logging entity of type info, trace, debug, warn, and error as sinks. So the first question that I'm going to ask is whether we have flows between any function that either initializes or deals with the model user that flows into the logger. Notice that this is a common strand across every recipe I'm using the same Fluent API, which is sync reachable by source. This is almost like establishing that connection between these two nodes. And voila, we came back with results. And if you look at this trace log, it establishes point of emergence, which is the do get request. And inside the point of emergence, we have a string being built and eventually being piped to the log file. Now, this is common, and this is not an anti-pattern. So let us go ahead and enhance our query to ask whether a potential anti-pattern exists. So the important thing to ask is whether we have, between the sink and the source, have we initialized or conducting any encryption? Because I've created, as an engineer, I've created a common function that does encryption, redaction, or obfuscation. Now note that these are patterns, and we have, as batteries included, provided matching for all potential patterns adhering to libraries like ES-API and others that exist produced by the community. But I guess as application stewards in your specific business line, you'd have written your own functions and your own packages. So having this Fluent API gives you the facility to introduce your own objectives and policies. So in this case, I asked this question of whether from the point of creating the user model to the log, are we conducting any encryption, redaction, or obfuscation in between? And the answer is no. So I'm going to switch this query over and ask a passes not, which means that there exists a path, but there is no encryption, redaction, or obfuscation. And of course, yes, I came back with this trace again. So lastly, I'm again going to take this this flow trace and communicate back with the engineer to let him know that this piece of code is in compliance violation. So let's traverse back to our GitHub link. We have only 2 issues, and since I created, there is a 3rd issue being created with sufficient data of the flow trace with line numbers so that the engineer can identify the context of conveyance and takes appropriate steps to triage and